Okay, so we're going to look at one more type of optimization question, and it has to do with geometry. So we already dealt with economics, so now we're going to go back to geometry and see if we can do this. So in this question, you have 1,000 feet of fencing, and you want to fence a rectangular area which is bordered on one side by a building. So first, let's draw that. So there's a building on this side, so we're going to call that the building, right? And this is a bird's eye view, so we're looking down, and I want to fence off a rectangular area, right? So this is my fencing here, here, and here. I have 1,000 feet of fencing, and you want to fence a rectangular area, okay? Well, I want to figure out what the biggest area is. So remember we talked about dependent and independent variables. Well, here the dependent variable has to be the area. So I need an equation for area. Well, area is length times width, right? And let's call this the length, and let's call this the width. So that's the width as well, right? Now, I can't have an equation with two independent variables, right? So what I need to do is I need to get rid of one of them. Well, we also have this information of 1,000 feet that we haven't used. So if this is W and this is W, and the total is 1,000, then the length has to be the total 1,000 minus 2 W's, because that's what I've used already. So that means that the length has to be 1,000 feet minus 2 W. So now what I can do is I can take this and I can replace that length with it. So that means that the area is actually 1,000 minus 2W times W. And now we have an equation with the same dependent variable, so just one variable. Okay? Now, I have an equation for area. I want to figure out what the biggest area is. So I want to find the optimal value. In order to find the optimal value, I have to find the axis of symmetry, right? Now, this equation, so I'm just going to change this to x's and y's just so it looks more familiar. So 1,000 minus 2x times x, okay? I have it in factored form, right? So that means that I should be able to find the zeros, find the axis of symmetry between them, and then find the optimal value, okay? So that means I'm going to do this two different ways. So option one, I'm going to find the two zeros. So zeros mean I'm going to let y be 0, and I'm going to do this. And now I know that if two things are multiplying to make 0, either this is 0, which means that's 2x, which means x is 500, and the other option is that x is 0, right? So that means that my axis of symmetry is x is 0 plus 500 divided by 2. So x is 250. Okay? Now remember up here, x actually means the width, right? So that means the width is 250. Okay? Now remember the length was 1,000 minus 2 widths. So the length is 1,000 minus 2 times 250, so 500. And this is all feet, because my original question was in feet. So 250 feet, 500 feet, and that means that the area is length times width, which is 125,000 square feet, right? So that's one way that we could find the area. The other way that we could do this is, because of course, remember, we have multiple ways of finding the optimal value. So our option 2 is to find the axis of symmetry from standard form. So in order to get standard form, I have to expand this. So I get 1000x minus 2x squared. I rearrange it because I always want the squareds to go first. So negative 2x squared plus 1000x. So in axis of symmetry says x is negative b over 2a, which is negative 1000 over 2a. So negative 1000 over negative 4, which is 250. So x is 250. All right, so notice that we're getting the same answer. It just depends on what you're more comfortable with. Are you comfortable with using factored form, or are you comfortable with using standard form? So if x is 250, again, the width is 250. That means the length is 1000 minus 2 times 250, so 500. And again, it means the area is length times width, which is 125,000 square feet. Okay? So that's that optimization problem.